Let's build your first machine learning project together because it's a lot simpler than you think. If I tried to describe machine learning to you in just one sentence, I would call it a process where you give a computer lots of examples and it learns the underlying patterns behind the data without you having to explicitly say them. Today we're building a machine learning model that predicts an apartment's rent price based on its square footage. The first step is always to import our libraries, which are basically pre-made tools that we can use in our code. If you're not sure which libraries to use in your code, you can refer to this guide, but also just remember the main four libraries. Pandas for arrays and data, NumPy to work with math, Matplotlib to visualize your model, and scikit-learn for a huge machine learning toolbox. Today we'll need NumPy, a few tools from scikit-learn, and Matplotlib to make a pretty cool graph later on. And remember, if this is your very first time using these libraries, then you must permanently install them in your terminal just once before importing all of them. Now we're transitioning into the training phase. When you're training a machine learning model, you must always begin by giving it data to learn from. Take a look at this example dataset. The X column is called the input or the feature, and this is the information we are giving to the model. However, the Y column is the output, also sometimes called the target or the label. This is the answer we want the model to predict. In our machine learning model, we've written a tiny synthetic dataset with just 10 points. The inputs are labeled X and represent the square footages of each apartment. On the other hand, the list of outputs is called Y, and each one labels the corresponding X value with the apartment's rent. Now that we have our data, we must split it into two parts: training and testing sets. Training data is what the model is allowed to see during the training phase, and it lets the model learn the relationship between square footage and rent. Then after the model is trained, we're going to use the testing data to check how well the model can make predictions on top secret apartment data that it's never seen before. The model should never see the testing data during the training phase. We usually take 80% for training and keep the other 20% for testing, so we're doing the same with our model today. It's time to actually train our machine learning model, and even though this just looks like one tiny line of code, it really holds so much power behind it. It's the most important part of the model. Today we're using a linear regression model, which is going to learn the relationship between apartment size and rent and draw a line of best fit through the data. The line follows the typical slope-intercept form that we've all learned: y equals mx plus b. This equation has two parts. First is the slope, which tells you how much the rent price goes up as the square footage goes up, and the intercept, which is where the line starts. Now that we have a fully trained model, we're going to use it. This is where our top secret testing data comes in, but it's actually not so top secret anymore because we're feeding it to the model. We're feeding the model only the inputs from the testing data, which are the square footages, and asking it to predict the output, which is the rent. And now we can check how well the model actually did in this task. To evaluate it, we use something called mean squared error. All that means is that we take the difference between the predicted rent and the real rent to get the error and then square that value. Once we've done that for every point, we add them all up and then take the average to get the mean squared error. We want a lower mean squared error because that means the model's line was closer to the data and had less error. The final step is to visualize and interpret our results. Use Matplotlib to plot the apartments as little dots and draw the model's line on top. The result makes a ton of sense. As the apartment's square footage increases, so does the rent. Finally, the fun part. We can even ask the model to predict for a real-world customized input, so let's try this for 950 square feet. We type in our square footage of 950, and the model gives us an output of $2,325 per month based on our data. And that is machine learning in its simplest form for you. So don't forget to save this video for your first machine learning project and follow for more. See you in the next one.